Hi everybody, welcome. Thanks for coming to our talk. My name is Birgitta, this is Lukasz, and we both work as developers for a software consultancy called ThoughtWorks, based out of beautiful Hamburg in northern Germany. And we found ourselves together at an inception workshop for a new project earlier this year in January with a new client who came to us and asked us to build a web-based internal application for them, and they said that they wanted it to work offline as well. So this is another colleague of ours, also a developer, and maybe if he had been with us at the time, he might have, made a face like this maybe, because if you're used to building web applications in a way that you can assume it's okay if they fail, if there's no internet connection, then when you hear your application needs to work offline, you might think of things like data synchronization, merging, conflicts, race conditions, how do I even test this? So all these things might pop into your head. And we want to, in the next 45 minutes or so, we want to take you through our experiences on this specific project and one other project, so that hopefully you can figure out if this requirement would feel like a nightmare to you, or if actually would be something that, like a nice little challenge that afterwards you could laugh about. And so we set out to do this project, and the first thing we needed to figure out was what does offline even mean, also in this context. And I don't know if you guys have ever asked yourselves why the Google Chrome team changed the, pointer even works, changed the sad smiley face to the T-Rex. I'm assuming it's because the T-Rex cannot reach the internet, right? But you could also say that maybe the T-Rex is a dinosaur, so whenever you're not connected, it's like you're in the Stone Ages, right? And I'm sure for a lot of people in this room, it feels for you like you're in the Stone Ages when you're not connected. So, and while a lot of people are, more and more people are online all the time, there's still a lot of cases, as we all know, where internet is at least flaky, like on the train or in a hotel or at conferences, other conferences, of course, not this one. It's something that can happen, right? And so what does this mean for our architecture?
Yeah, and before we start with this and talk about the technologies we use to implement that, let's think a bit how this all started. So yesterday I was listening to a talk about modern web architecture, and I've seen an amazing example of a static HTML website which is still online, Space Jam film. And if you haven't seen that, go look it up because it's amazing. So everything started with quite stupid client, I would say, because we used the browser only to render the content provided by the server, and the server was responsible for everything. So there was, like, without the connection, there was actually nothing to do, no like logic on the client side. Then we somehow discovered JavaScript, and Ajax happened also, and we started to work on these rich internet applications where we had more and more logic client side. And then we also communicated with multiple services, and at this point we could potentially think already about how maybe I should provide this functionality also offline, but somehow this didn't happen. The server was still in charge, although the client was also possible to do a lot of stuff. And now we found ourselves in the situation where we actually said, okay, because we need to implement those offline capabilities, we could think about the client as an independent client. Because now the client needs to somehow cache all the code which is needed to run in the browser, and also provide some kind of data storage locally. So therefore the connection is actually not necessary. As long as the user visited once your website, it will be everything what is needed will be actually downloaded. So how can you do that, and what does it actually mean? At this point in time you will probably ask the question, okay, why? Why are you doing something like this? Why is it even important to provide something like this? In our case the answer was quite straightforward. We had two customers and they said this is very important to us. And the first customer, they wanted to have an internal application for a traveling user. So the user would go to a very remote locations somewhere in Asia, go to factories and basically check if the quality of the merchandise was okay and good enough. And as you can imagine, when I go somewhere very remote, I cannot actually rely on a very good connection. I don't know if I have internet connection, and even if I do, I need to struggle with latency and all that stuff. So for that reason we needed to somehow think about it and make the application which was running in Chrome be available in this kind of setup. In the other setup, or on the other project, we were working for a retail company like a supermarket chain, And they wanted to have an application which were used in a store, where people basically walk around the store and updated their inventory system. And if you imagine if you go into this walking freezer, they're not only very cold, but they don't also have very good internet connectivity inside of them. So as you see here, those two projects were very different in regards to how long one user stayed outside of or how long the period of the inconnectivity was. Because the traveling person could go on a journey for 1 week or more, and the guy walking around the store could lose a connection for multiple minutes. But why is it important for you? You will also ask. The funny thing about this is that if you actually support this offline capability, you will see that your user experience of the application will be much, much better, because then you are not relying on a very good internet connection. You can basically compensate for any latency or flakiness in it.
Yeah, so how did we do it? So the case of the person that travels to factories was actually the project that Lukasz and I worked on for most of this year. I'm actually still working on it, and the supermarket project was done by a different ThoughtWorks team in the UK. So we know less about that project, so most of these examples will be about the traveling example. And the first thing, so the first step we needed to do, Lukasz already mentioned it, we needed to make sure that the source code of the application was available offline. Usually the whole idea of a browser is you don't need to install anything, you just need to install the browser, right? But in our case, we needed some kind of installation. And so you have all those clients, you have your static resources, JavaScript, HTML, CSS, images, and so on. And what we used for this, and it's the first HTML5 technology that we're going to mention today, out of 4, I think. So how many of you have used App Cache before? It's actually been around for quite a while. Okay, a few people. So the way App Cache works, it's actually at first sight pretty straightforward. So all these clients, the first time they access the application, they download file by file. They download all the resources they need, and then they put them into the App Cache in the browser. And then from then on, that's available for them there. So if you imagine that a few of them go offline, then they will just be able to still continue working with those files. If there's an update of your application, so you have a new deployment, what happens then? So in that case, all the clients that are online, they will just get the new distribution, and the ones that are offline will just continue working with the old one, and then once they're online, they will get the new files. So pretty straightforward at first sight. And it's also not a lot of implementation effort, so there is an attribute in the HTML tag called manifest, and you reference a file there. Doesn't matter what it's called, you can call it appcache.manifest, for example. And then in that file, you configure which of your resources you want to be cached in the clients. So it's just a straightforward list of files under this cache line 4. And then also it's important that in this other area, in the network area, if you just put a star, just whenever the browser cannot find a file in the app cache, then it will just try to access it via the network like it would usually do. And then you can also provide a fallback if the browser cannot find a resource in the cache, neither in the cache nor over the network, then you can show this fallback file. And so how does the browser recognize that there's a new distribution available, right? So how does it know there's version 2.5.4 now available? And that's actually just the browser regularly checks, is there a new manifest file? So you need to make sure that if you have new resources, that this file is changed. And at first you might think, yeah, of course, if I have new resources, they will just be put in there and then, it's no problem. But usually nowadays you minify stuff, you concatenate it. Like in our case, for example, we just have this scripts.js and that's all our JavaScript. So this file basically almost never changes. So the simplest way to do this, of course, is you already see it probably in line 2. You just put a timestamp in your file. And there are tools that can help you with generating that. So we use Grunt for our client-side pipeline, for example, and that just generates that timestamp in there every time we build. There are also a few browser events that you can hook into. So, for example, checking tells us that the browser is currently checking for changes of the manifest. Downloading is like for each file that it downloads, there's an event that says I'm currently downloading. And the most important one is update ready. Update ready is an event that gets thrown when the browser is done downloading a new version of the cache. And actually, when it's done with that, it doesn't do anything else. So the user will still see the old page. So as a developer, you have to decide what you want to do. For example, you could show them a dialog to say there's a new version of our application, please refresh. You might have seen that in Gmail, for example, or in other Google apps, they sometimes do that. And another thing that we did, for example, by hooking into these events while so we had the user refresh the page, and then while it was downloading the files, we showed them like a loader image. And then when it was done, we could just hide that all by hooking into those events. So that's all pretty straightforward, but you actually also have to be very careful because this is an additional cache, right? There are already a lot of caching layers out there. The browser does some caching, HTTP does some caching, so the easiest trap that you can fall into here is, of course, if your manifest file is cached, right? Then you're basically like a colleague of ours always says, you paint yourself into a corner, right? So you can never get new versions of your application to your client. So that's the easiest trap. So you have to be careful how all those caches play with each other, and there might be weird behavior. And there's actually a nice article. It's called "Application Cache is a Douchebag." It's already 2.5 years old, but it still gives a very nice overview of like the traps that you might run into when you use these, and how these different caches might play with each other and how those updates work. And it's also, App Cache has been around for a while now. It's supported by all the common latest browsers, so it's pretty safe to use it cross-browser today, if you really need it.
Okay, so now we know how we actually can get the necessary code and resources to serve the application offline. But what's the point if we don't have any data to present? Like, the whole application doesn't make any point if you cannot present any data to your users. And if you try to do that, like provide any offline capability for your data, so you search for how to store data offline in a browser, then one of the first hits you will see is actually web storage. One of those HTML5 APIs all the modern browsers right now provide. And the whole concept is very simple because it's an easy key value store you can use. You can basically access the object directly from the browser, say, okay, local storage.town, I say equals unfairpen, and so you created the first entry in your web storage. There are two implementations of that. The first one offers you persistent storage. This is called local storage, and the second one will be cleaned after either the browser will be closed or the tab you are running in will be closed, and it's of course called session storage. And it's actually as simple as it can be. It offers you a synchronous API. It has some limitations. For example, the amount of data you can actually push into that storage is limited to around 5 MB in Chrome, but it gets the job done if you need this kind of functionality. So if you think about the first use case we had with the guy running into the walking freezer for a limited amount of time, it's probably not so really realistic that during the time more than 5 MB of data will be generated by him typing on his keyboard or iPad or something.
And they actually use local storage for that on that project.
But if you have other kinds of requirements, for example, if you know that your user will actually use your application in the following setup, that they run multiple tabs, and each single tab is basically another instance of your application, and every single instance will try to access the storage, then you see that it would be probably nice to have some kind of transactions or those kind of concepts you know from databases. And therefore we needed to search further because this was one of the very common user scenarios for our application. And if you search further for other APIs offering you offline storage, then you will quickly run into IndexDB. IndexDB is basically a database offered you by the browser, and it's written in JavaScript, of course. And it's actually quite simple to use. As you see here, this is actually the Chrome developer tools. Everybody knows that, yeah? So in the resources section, you will see all the different storage or APIs you are using. And as you see here, For example, it's showing us the database which are registered for a particular domain. So this is also an important concept here, that every single API you're using is sandboxed and it's bind to your domain. Only the code coming from your domain can actually access that content. And this IndexDB offers you not only global transactions, providing some level of support for concurrent access, but also is able to store much more data than local storage. And also, on top of that, it's called IndexDB for a reason. You can define indices on your object stores, so you can even realize some kind of simple search capability when offline.
Though you have to be careful what you really want to do. So some of you might also have recognized Web SQL up there. It's still there, but it's deprecated by now. Actually, it was a try to get SQL into the browser, so where you could have done really powerful queries. But in IndexDB, it's really quite simple. So you have those indices and you can query those, but you cannot do any aggregation or stuff like that. So if you want to use this, don't make too many assumptions about the power of this. Like rather try out your use case first and see if it really works, because it's very basic, but for us it was quite useful.
Yes. And of course it's a schema-less database. And if you take a look at the API, it's a typical API story designed by a committee, so it's of course a W3C specification. Although it's quite easy to get a grip on the IndexDB, because it's yet again a global object offered you by the browser, everything is asynchronous. So because this is a central concept, a fundamental concept for your whole application, this asynchronicity will leak everywhere else, so you need to think about that. But as you see here, basically, right from that start, you have callbacks you can register. So whenever you have a successfully requested the database, you can open a transaction on a specific object store. Then you can decide if this will be a read-only or read-write transaction. So you see those are global transactions without a commit. And then you can basically query the database or use indices and open a cursor on this index and then iterate over that cursor. So it's very, very low level, and it feels kind of funny if you're coming with your Java background, you're used to using Spring Data or Hibernate or something, and then you need to do something like this in the browser. So it was quite funny feeling. Yeah,
we were quite surprised how low level it really was. I mean, this doesn't even have the code for the for loop, how we loop over the cursor. It was quite low level stuff that we had to do there. Yeah. And we had to wrap it well, and we didn't really find that many ready-made wrappers on top of this out there that were suitable for us. So.
Yeah, at this point, it's probably reasonable to say that we were building the application using AngularJS, so we quickly decided to provide a better suited abstraction for our needs, and we wrapped this in an Angular module which basically was working on promises instead of callbacks, because it worked nicer with us or with our design of the application. Yeah, but you probably also think right now that if we do something like this, if we do something like this, then you quickly are in the situation where you have all the different databases out there. You actually don't know what kind of data they're storing, because it's not like the full copy of your database you have on your server, and you don't even know in which version they are.
Yeah, so it's the same situation as the one that I showed you before, just now that it's databases, right? You have your central data store. In our case, that was or is MongoDB. And you have all those rogue little IndexDBs out there on clients that you cannot really control. And so what happens if you have an update of your data, right, in the sense of schema change? So now, technically, of course, MongoDB and IndexDB are schema-less, but you always have a schema in your application, right? Be it just the contract between your UI and your data, and sometimes you want to change that. There's changes in your domain, and you want to move stuff around because it doesn't really fit anymore, or other structural changes, and your UI might not be able to deal with the old data anymore. So we had to deal with that as well. And so how did that work? So the first thing we did when there was an update, so of course not every single one of our deployments or versions has such a change in it. So those are kind of special deployments when we have like a schema change, as we call it. Then when we have that update, first thing we do is, so we're using a Spring application in the backend. And when we start up the Spring container, we run the migrations that we need to do on the MongoDB, so that we have our central data store in the state that we want it to be in with those changes. And then the next thing we do is once the first client, after we have deployed everything, once the first client accesses the server again, like I showed you before, we deliver all the new JavaScript, and then that JavaScript actually tells the IndexDB, you're not version 15 anymore, you're now version 16, for example. Because IndexDB, that's another feature it has a very simple little mechanism to version it. So with just say you're 15, you're 16, 17. And when you tell IndexDB you're now in a new version, then it will give you a few events that you can hook into again. So in our case, this important event is called onUpgradeNeeded, and then we can react on that and also run migrations on the data in the browser. And this was actually a very nice little use case for us to use Nason, the JavaScript execution engine in Java 8. So we have the migrations all implemented in JavaScript, and then we share that piece of code between the clients and the backend. Yeah. And next one is, I think, yeah. So we've talked about data, like JSON in JSON format. I don't know if we even explicitly mentioned that, but it must have been pretty obvious that we were dealing with documents. But our client actually also wanted us to enable the creation or upload of images, even when you're offline. So we needed yet another HTML5 storage technology for this, which is the file API. Yeah. And as you can see here, the first time when you use that, the user will be asked if it's okay to permanently store large data on your computer, and then they say okay, and then that's usually stored in the settings, and then it's okay from then on. And just to give you a rough idea of what we had to do to support this for images in our case. So the first thing you need to do is set up the file system, kind of say, yeah, I want to access it at some point, and you can also request quota. So the file API is actually the one among the storage technologies that the browser will give the most access to from the storage pool that it actually gets from the operating system to write to. So you can store a lot more data through the file API than through the other storage technologies. So you kind of set up like how much space you roughly want to use, and then when the user says I want to upload an image, the first thing we do is we store it locally, and then once it's stored locally, it's actually accessible through a specific URL pattern. So it's file system : HTTP, then the domain, as Lukasz already mentioned. So you always tie your data to a domain, so there's no cross-site scripting, /persistent/ the name of your file. So once we have that file stored and we have that URL, we actually have to update the image source tag. Because, I mean, storing it locally is usually pretty fast, but if, for example, there was for some reason it would take a lot of time, then we would only have this URL once it's really stored, right? And then we upload it to the server. So really it was also like kind of an offline first approach. This is what we did from the beginning. Then the other way around, when you get the image, so you're now a different user and you want to get that image, we first start download from the server asynchronously in the background, then we store it locally, and once we have it, again, we have to update the source tag. So in Angular, it was very suitable for a little directive. So that directive knew the name of our image and it knew how to get that image from our server. And then initially it would just show like a loader as long as it was downloading it, and as soon as it had the URL available to the persistent file, it would update that source tag and show the image to the user.
Yeah. One thing to notice here is maybe some of you are asking yourself, okay, why haven't we pushed the images into the IndexDB? There's a reason for that. All the IndexDB and also the web storage APIs, they support only strings as values. So if you would like to do something like this, you would need always to base64 encode that. And this is basically like spinning CPU or using CPU cycles if you don't really need it, because it's much easier actually to put them on the disk like this. And this was working very well for us. Okay, so now we reach the point that we have the client offline, we can access, we can go without the internet connection to the browser, hit the URL, and we will be served our application, or we will see our application, and the application contains also data we need to access, we need to work on.
And we actually can already create some data offline with the images, yeah? So
yes, so this is also done. But of course, this up till the second step, everything is only read-only. So how can we actually achieve the capability or provide the capability for changing data even if we are offline? And it's of course all about data synchronization. And for this bit of functionality you need to implement, there are no HTML5 APIs in place. You can basically take and use out of the box and you are done. Here you need actually to analyze what is needed and what is your domain and how to work with this. So we divided, like when we needed to tackle this problem, we divided it into 3 sub-problems. And we said, okay, first thing, we need to know how to encapsulate the changes the user is actually doing in introducing into the data set. So we thought about this, and in the first, like in the situation where we had the user running around the supermarket, it was actually quite easy because you can see they are updating the inventory, so you can say, okay, I have some update commands, so I can use the command pattern, and this is my atomic encapsulation of a single change into the data set. On the other project where we had these huge documents which were created over multiple days, we couldn't actually do something like this. So we said, okay, instead of going with the command pattern, we will basically take a snapshot of the document every time it is changed, and so we always know, okay, what is happening and what happened actually during this offline period. So this was more the memento pattern approach. When you have all those elements, you then need basically somehow manage them when you are offline. So this will push you towards implementing a queue in your system, which will be then actually built on top of the storage technology you choose. So in case of the traveling person project, it was backed by the IndexDB. So what it does is basically stores all the events you push there in the right order, and whenever you are online, you can basically take them and go through them. And this is the third step you need to take or to implement. It's basically how do you deal with the processing of those items. And if you manage to say, okay, actually my entities, they consist of those events, and then you can say, okay, actually we know this kind of architecture, we go with this event sourcing approach on the client and on the server, and you communicate only the events back and forth, and that's then you are more or less done. In our case, we basically pushed the documents or posted the documents on the server endpoint, and then needed basically to react to the answer. What is also very important, you need to have some kind of or some scheduler in place, which will basically always check, okay, is the backend there, and if it's there, it will take the queue content and iterate over that and try to synchronize it to the server.
Yeah, so almost like in an extreme case, you could build a circuit breaker or something like that, and we've actually considered that to do that in our application as well, but it wasn't really, so we actually ended up with a simple ping, and so far that has served us quite well to check if they're online or not.
So what we do is basically we check every 5 seconds if our server is there, because of course it's not about, there is a HTML5 flag in the browser you can use, are you online or offline, and this is like a very simple solution, but it can be a little messed up if you have a connection to any kind of network, although you don't have the connection to the internet or to the system you would like to connect to. So for us, the better solution was to basically say we will do a heartbeat check on our backend, and if the backend was online, then we were online. So then we take the content of the queue and try to sync it.
And it's important to consider that this is not a public application, but once all the users have rolled on to use this application, there's going to be 300 or 400 of them. So for this case, so far I think this is going to be okay. So we'll have to observe that. One thing that's also interesting about this is that the differences between the 2 projects, the supermarket projects that a team did in the UK and our project, because So at first sight, it's like, oh yeah, this needs to work offline, this needs to work offline, but it can actually be quite a different solution. So in their case, local storage was enough. We actually needed IndexDB. In their case, they used the command pattern, and it was actually important for them in which order those commands would actually be played on the server. In our case, we had snapshots, basically just a little thing running in the background that would upload those snapshots and just overwrite them every time. So it was actually, in the end, at first sight, it looks similar, but quite a different solution.
Yeah, but as you probably already think, there is one term we haven't somehow mentioned, and of course, if you are offline and you work on something, and then you 1 week later you get online, you will have probably a big problem if somebody else changed that. So you somehow need to deal with conflicts, and the first thing you do, you will implement some kind of conflict detection. And in our case, it was pretty straightforward. We introduced basic unique client IDs and unique version numbers. So basically what the server did was only to compare if they change and if there is a conflict or not. So if I tried to push something to the server after I reconnected to the network and the server said 409, we then needed to somehow deal with this. And at this moment in time, we ask ourselves, okay, how much time do we want to spend on that? Because like conflict resolution, as everybody knows, can be a rabbit hole, and you can go into fancy merging strategies and all that stuff. So we decided basically to talk to our client and to ask them, okay, how often can it actually happen, and how much time should we spend on that? And in the end, they said, okay, it's not a common scenario, so it's totally okay for us if you basically say there's a conflict and prompt the user to choose either the one or the another, even if there would be some data loss there. Okay.
Yeah. So I promise you that we would like to try and help you consider if you ever come across this requirement, is this going to be like a small thing to build, or is this going to be like a total nightmare for you? Because so we came up with a few questions that you might ask yourself to see, is this going to be like hugely expensive, like 2-year effort, or maybe it's doable in 6 months, or whatever your timeline is. So the first one is the size of your data, right? So we talked about how local storage only takes up to 5 MB, and with IndexDB, you actually, and File API, you actually have a lot more data storage space available. And of course, you probably also noticed that local storage is a lot simpler to use than IndexDB, because IndexDB comes with a lot of extra features, but that also means more complexity, right? So if you have to store more data and you also need those transaction capabilities that we showed you, then your application is going to be more complex, as if you only had to use local storage. And also you have to think more about how do you clean up after the user if they've like accumulated a lot of data, because actually the browser has, it's actually quite hard to research how much storage space you actually have available. So in Chrome, there's a white paper from Google that describes that, and Chrome gets 50% of the current storage space available on the computer, has it available, like maximum. And then each application can have up to 20% of that. So but that also means that if you don't even use those applications, but you create more data on your disk, the next time you bring up the browser, you actually have less of that maximum, because it's always 50% of the current storage space available. Yeah? So it's a bit complicated, a bit hard to find out, but you have to have some strategy of how to deal with like quota exceeded errors, I think they're called, right? And how do you deal with that? Is it okay for your users to every now and then just clear it if they don't actually need it offline, and so on? The other one is the structure of your data. So, for example, if you have a lot of separate entities that have lots of relationships with each other, it might become more complicated, because already if we only consider the server, we have situations where we want to delete something and then we need to check, is it used anywhere? Then maybe you're not allowed to delete it because there's so many references. And now if you also have that problem on the client while they're offline, it becomes a lot more complicated. Obviously, it's a lot easier if your central data store supports the same structure as your client data store. So in our case, both of them supported document. And if we had had a relational database in our backend, we would have had to build a lot more mapping and stuff like that, and would have become more expensive. This is something that we haven't even mentioned yet, sensitive data. So fortunately, we didn't have to deal with that. But if you imagine that you might have credit card data or stuff like that you want to store there, then maybe I would think again and try, and I actually wouldn't know. I think I would try to not store them offline, maybe. Because then you get into like using encryption with JavaScript in the browser and
maybe not a bad idea.
False sense of security, yeah. Potential for data conflict. So Lukasz only touched that topic very lightly. So in both of these cases, the supermarket and the traveling tester, we were lucky that the client said we actually don't even want them to work on stuff at the same time. It might happen, so we need some basic conflict detection, but we don't want them to have like sophisticated merging or stuff like that. So if you consider your requirements and you see that you actually need to implement all those things, then you immediately know, okay, this is going to be a big thing, and otherwise maybe you can push back on a few things and ask your stakeholders if they really need this, because this is going to be a big part of your implementation.
Yeah.
It's an obvious one.
Yeah. Whenever you talk about web applications, then you will touch the subject of browser support. And in our situation, we were very, very lucky, because I think in both projects we were able to pinpoint the exact browser we would like to run with. And of course we choose Chrome.
Both internal applications, so we could really fix it.
Of course we choose Chrome. Of course we went with the newest version. So we had support for all the APIs we just presented without any afterthought. But if you are working in a company where this is not possible, and I think most companies will need to support some kind of users working with Internet Explorer, then it tends to get a bit more tricky, because then you need really to analyze, okay, if I'm using, for example, IndexDB, how good are the implementations of all the IndexDB features there and all that stuff.
And IndexDB is the least supported, I think, of the 4 that we just talked about so far. I think in Internet Explorer it's starting from IE 10, I think,
yeah,
right?
I think so.
But even like for public-facing websites, we recently talked to somebody from Sechs Wunderkinder in Berlin. I don't know if you know that company. They do an app and a website called Wunderlist, and they actually also use IndexDB to store their data locally to make their website more robust and to give like a better experience on a flaky connection. So if you, it's not, and they accept that maybe somebody who has IE9 cannot use that.
So you can also always use some kind of polyfills for that, but we also seen a problem with that. Sometimes we were using Karma as a integration test runner, and with Phantom.js, and Phantom.js of course doesn't support IndexDB, so we introduced a shim trying to mimic that API, but it was based by WebSQL, and then it behaved totally differently, so then we switched basically just to Chrome.
Yeah. So also an interesting sign of the fact that we actually didn't feel like we didn't really like the IndexDB API that much, as we mentioned before, and like a sign of the quality of the API is also that we had a lot of trouble mocking it. So we tried, we wanted to have some level of unit testing in that area, and we tried to mock it with that shim, and then it didn't really behave the same, and we didn't want to write it ourselves because we didn't really at that point really understand what was going on in IndexDB yet. So we actually ended up having integration tests for that and no unit tests.
And another part about the browser support is that sometimes, although you're using the same browser, if you're using the same browser on a different platform, for example, if you're using Chrome on an iOS device and Chrome on an Android device, it can behave totally different. So also think about that.
Okay, this one seems like a pretty obvious one, and kind of gives me a nice segue into our last part, like the 3 big things that we would like to leave you with. So how much functionality does really have to work offline? Like I mentioned the example of the merging before, and also in our case, not all the features in the application really work offline. So we focus on the ones that are really most important for the type of user that is traveling, because not all of the users are doing that. At the same time, we still try to use the same storage concept for the most part of the application, so that we could just build that in from the beginning, because it was kind of a core of our architecture. And so this is something that we would like to leave you with, that you, if you have this requirement offline, really figure out what does this mean for our case, and talk to the stakeholders and try to figure out, maybe with a set of those questions or some more questions, what is really needed. And because I haven't seen an XKCD yet at ThoughtWorks, I also put one in here for this. Yeah, we'll let you read it.
I hope they like it.
Yeah, it's a pretty recent one. I quite like it, and it kind of shows that obvious concept of, it's kind of hard to sometimes to explain to your stakeholders why it's very easy to do conflict detection, but you might need 4 months to do or 6 months or whatever to do merging and sophisticated UI for that, and why you don't want to custom build that maybe.
Yeah, and there's also the other part that you should push for implementing some of those features very first in the very early stage of the project. Because as you've seen with the whole data synchronization part, it's a very fundamental decision you will need to take. How actually to encapsulate all those changes, and how to write the queue, or what kind of queue implementation you would like to have, and all that stuff. So this will actually impact a very large portion of your code base. So it's very helpful to tackle those kind of problems very soon.
One thing that bit us was that we actually started off with local storage. Because we were like, okay, let's just take a simple approach first and then really figure out on the way what are really our requirements. And then we found all those things. We need more data, we need those transactions, all those things. And then we had to switch from local storage to IndexDB. And as we told you, local storage is synchronous API and IndexDB is asynchronous. And of course, the storage is like the last point in our chain of calls that we do. So we had to put that asynchronicity in basically throughout our whole application. I think we worked on this for a week or 1.5 weeks, or it was a story from hell, kind of. But we still caught it very early, so maybe that was after a month or so, right? So if we had only noticed that after 2 or 3 months, then it would have been a lot more effort, because it really touched almost everything in our code. Yeah.
But we also learned from that, and what we then decided is to, we had this concept of this asynchronicity in all the code, and we had the queue, and then we basically said, okay, there's no point in differentiating between am I online or am I offline. We will basically send everything through that. So this was a very nice concept we could work on, and it basically resulted in a very robust architecture of a client application.
Another aspect of this is not only is this important for the technical part, but it's also very, very useful if you can get these types of applications out to actual users or pilot users or something like that very early on. That's what they were able to do in the case of the supermarket. I think after 2 months or so, they had a pilot store that they could always that they could use to test the application. One side of that is that there can be a lot of weird edge cases with this type of data synchronization, and you cannot just anticipate all of them and just, in case they might occur, just, build fixes for all of them, because it's very small things that maybe occur in only a few cases, and you have to build a lot of complex code for it. So they could actually, with that testing, they could identify the edge cases that actually occurred and then fix those. And the other thing is usability as well, because, we're all getting more and more used to, because because of mobile devices, that stuff is syncing in the background, right? But there are still a lot of people who don't really know what's going on there, and it might be important for your application that the user really understands what data is offline, what data is online, what does it mean, local versus on the server. In our case, for example, we are doing all this saving in the background, so automatic save. So there's no save button, right? But our users very early on said, "Where's the save button? Where's the save button? I want a save button. Why are you not giving me a save button?" And then we had to kind of, in this case, of course, we didn't change it. We didn't give them a save button that didn't do anything, but we could kind of had a chance to educate them about it, and also come up with a few other concepts about colors, for example, that would really indicate to them if they're online or offline and things like that. Knew this would happen.
Amazing.
With 2 clickers, right? The last one is just, explore the possibilities. So even if you don't have this requirement, maybe a few of you are already using these things if you're building mobile-centric applications to make your application more robust, right? So it's not only for this quite extreme case, I have to admit, but these storage technologies are becoming more and more mature, more and more browser support, so they can, they might be able to help you to make your application more robust and also to slim down your session, right? So if you can store more stuff in the client that the server doesn't actually really need to know, ideally the server only needs to know like a session ID, right? So it can identify the user session. But a lot of the other data that sometimes you put into the payload of a session, you can actually now store in the browser. So maybe explore those possibilities.
Yeah.
Yeah, and that's it.
And now that's the last one, yeah?
Thank you.
Okay.
And we still have a little bit of time, so.
Yeah, actually a lot of time. So thank you very much for your attention. Danke, that's what thank you means in German. And if you have any questions, I think we've got mics there, and I don't know if there is something, but just grab a mic and try to ask it. We'll definitely try to answer it. And if you don't see a mic, just shout at us and we will repeat and try to deal with that. No, it doesn't look like it.